This video is supported by the NDLR and the Department of Mathematics in NUI Minute. In this video I want to talk about sequences. A sequence is really just a list of numbers, so let's have a look at some. Let's consider the sequence with elements 2, 7, 27 and 50. The first thing I remark is that this is a finite sequence, and the reason for that is that we just have these 4 elements in it. The second thing I notice is that there doesn't appear to be a pattern or a rule governing how I go from element to element, or from 2 to 7, 7 to 27, 27 to 50. Now let's look at this sequence here. Again, it's a finite sequence because we simply have the 4 elements 2, 4, 6 and 8. But this time there does appear to be a pattern. 2 gets added to 2 to give me 4, 2 gets added to 4 to give me 6, and 2 gets added to 6 to give me 8. Now let's look at this sequence here. It has the elements 3, 6, 9, 12, and so on like that forever. So we would say that this is an infinite sequence. Again, this time there appears to be a pattern, because 3 gets added to 3 to give me 6, 3 gets added to 6 to give me 9, 3 gets added to 9 to give me 12, and so on like that forever. Now we frequently give sequences names. So for example, we might call this sequence here AN. We might call this sequence here BN. Or this sequence here CN. We also sometimes like to label the elements in a sequence. So because this sequence is called AN, we would call this element A1, this element A2, this element A3, and this element A4. Similarly, because this sequence is called Bn, we would call this element B1, this element B2, this element B3, and this element B4. So frequently in mathematics, we are interested in patterns that might appear in numbers, and any kind of formulas or rules we might be able to extract from those patterns. So if we consider this sequence here, we might like to come up with a formula that would generate all the elements in this sequence. So hopefully you can see that a formula for the nth term, or any particular term that we would like in this sequence, would be given by the formula 3n. So let's think about that. If we wanted the first element in the sequence, well, 3 times 1 would give me 3. If I wanted the second element in the sequence, we'd have 3 times 2 would give me 6. The third element, 3 times 3 gives me 9. And the fourth element, 3 times 4 gives me 12. And so on like this. So we can see that this little formula here would generate all the elements in the sequence. So if we wanted the 50th term, the 200th term, or the 2000th term, we would simply plug it into this little formula here to find out the value of that term.